I want to talk about making decisions on our null hypothesis test. So in the top, I have a two-tailed test. So this is an example of two tails, okay? And so that would be something like the null is the mean equals 0, and the alternative is the mean doesn't equal 0, okay? So then you always have a positive and a negative version of whatever your critical value is, and you cut your area in half. So if I want a 0.05 significance level for this one, I would have 0.025 in each one, okay? So this would be significance of 0.05, okay? And it would have 0.05 to 0.25, and I would look that up. Now, I don't know if this is the right, it probably is for a t-test. No, it's a one-sided t-test. But anyways, I just made up values to go with it. But anyways, so I'm going to erase these because they don't go exactly with what I want to do. But oh, I think I can make this bigger. Anyways, the point here is that I'm going to have some values, and I'm going to do positive or negative. So say I got a t-score or a z-score or a chi-squared value of 0.01. Okay, so say and I'm going to just go with a t-score. My t-stat was 0.01. This falls between these in the white area. That means I fail to reject. To reject, I would have to be less than negative 1.67 or greater than positive 1.67. So I have to be in one of the orange areas, okay? Orange areas mean reject. Now, what does that mean? Well, if I reject, that means I can say that my null is true. So in this case, I could say that the mean does not equal 0, or doesn't equal 15, or whatever I set it as. Okay? If I fail to reject, that means I can't prove that it's not equal to, but I also cannot prove, I never prove this. That's not what this test does. You can make a loosey-goosey assumption that, okay, it's probably then about them, but you can't prove it. If you do reject, you're able to then prove it with sufficient evidence, statistically significant, that it's true. Okay, but if you fail to reject, it's a non-starter. It means, okay, I can't prove anything else. I need to go back and run a different test or run this test a different way. Sometimes merely just, okay, I wanted to prove under 5. Well, maybe I can only prove under 6. Okay, I can't get down to 5. I can prove it's under 6, but I can't prove it's under 5. Usually you can only get so close to the actual value. Okay, so if I fall in the orange rejection areas, I get to reject. Okay, the colored areas, the tails are my rejection area. That means I get to reject. If I don't, if I'm in the middle, I fail to reject. Reject means I get to prove something. I get to prove whatever my alternative hypothesis was. If I fail to reject, that means I can't prove my alternative, but I also can't prove my null. Now, what if I had a one-sided test? The difference is this is a greater than. So this is a one-tailed, okay? And this would be something like the null p equals 0.2. The alternative is p is greater than 0.2. This is greater than because it's in the positive end. You have to prove it is larger than your positive. Positive, okay? This is greater than, okay? This is positive, and I want it to be bigger. So like if I had a value here of say 0.301, I would be able to reject the null, and I would be able to say that the proportion is greater than 20%, better than 0.2, okay? I only care about that end. And my whole, whatever my whole thing, if I have a significance level of 0.05, this whole thing would be 0.05, okay? I don't have to split it between anything else. The other one-tailed is a less than test, and you can see this is also one-tailed, but this is less than. So now my alternative would be p is less than 0.02, and I always use the negative value. Okay, and in any case, to reject, my value has to fall in the tail. I can either have 2 if I'm not equal to, or one or the other. Okay, if I reject, that means I am in that area in whatever color I decide to make my rejection area this time. Okay, and that means I am either smaller than the negative or larger than the positive. okay? And in a one-tailed, I only have one or the other, okay? Now, what does that mean again? Well, okay, reject means I get to prove whatever it is. If I rejected this, okay, so say I had, let's go with this. I'm going to go with t equals 2.2, negative 2.2. I would be able to say I reject the null, and then therefore I can say I do have sufficient evidence to say that the proportion is less than 0.2 with this t value. Now, if my t value had been 1.3, I would then have to fail to reject, and I'm unable to prove that the proportion is less than 0.02, but I don't get to prove that the proportion is 0.2. I can assume it's somewhere in the thing, and I can say, oh, probably I might want to run a different test and look into this, but the reality is this does not prove the null. I never prove the null. I only ever prove the alternative. The best analogy I ever heard was that the null is like a straw dummy, okay? I just want to knock it over. But I don't ever just want it hanging around. I'm not going to prove that null. That's just what I'm trying to knock over so I can prove my alternative, okay? So hopefully this helps you as you work through how to deal with these rejection and fail to reject decisions and what each makes, okay? Reject means you get to do something cool, and reject means you are in one of the tails. And that's the biggest thing you got to remember as you're doing this.